Hello everyone. Welcome to today's webcast, Simple and Powerful Self-Service Analytics. My name is Paddy Duraiswamy. I'm a Senior Business Intelligence and Analytics Consultant at Thorogood. I have been helping customers in different industries to enable enterprise-wide self-service BA reporting. I'm joined today by my colleague, Laura Haase, who is helping customers in the health insurance industry on dynamic reporting, and we will be sharing some of our real-life experiences with you today. So the objective for today's session is to share some of our experiences in order to help you understand how self-serve analytics can be enabled within an organization. As part of this, we will be identifying some of the key challenges that businesses face in self-serve reporting. At the heart of self-serve reporting is making secure access to data available to users at a performance level that is acceptable for the enterprise. We would be looking at how Microsoft Analysis Services provides an engine for this and helps open up managed self-serve reporting to more users within the organization. We will be demonstrating the solutions using some of the most commonly used BA tools in the market to help you understand the considerations in managed self-service reporting and highlighting areas that make it challenging to achieve. The agenda for today's session is to provide an overview of who we are, identify the challenges that industries face in implementing self-service analytics, followed by an overview of Microsoft Analysis Services offering. All along, we will have demos. So for those of you who are not familiar with Thorogood, we are a professional services firm who specialize in business intelligence and analytics. So we deal with strategies, solutions, and services. Our clients are some of the leading organizations in the health insurance, pharmaceutical and life sciences, consumer goods, property and casualty insurance, banking, and capital markets. And we service them globally by our leveraged teams from our UK, US, and Indian offices. We recruit and train consultants to have a unique mix of skills and in the same way across all of our practices. In terms of our approach, we combine business knowledge and understanding in industries and functional areas with excellent technical capabilities, as well as deep understanding of analytical techniques and tools. This helps us understand the business benefits and how technology can be used as an enabler. Here's a sampling of our client list from some of the core verticals like healthcare, pharma, property and casualty insurance, consumer goods, and financial services. As an independent consulting firm, we partner with a number of technology vendors in the BA and analytics landscape. At the top are the major BA vendors like Microsoft, IBM, SAP, and Oracle. For some of the specialist areas, we also partner with some of the niche vendors, for instance, Anaplan and TM1 for planning and budgeting, SAS for analytics, DataSift for social media data analysis. For today's session, we will be demonstrating how the Microsoft BA platform and Tableau can help solve some of the complex problems that we see in industries from a self-service perspective. At this point, I'll hand off to Laura to take us through some of the challenges in enabling self-service analytics.
Thank you, Paddy. So within the BI and analytics space, we are seeing a growing need for self-service reporting. One of the main drivers is that the questions businesses ask are constantly evolving. It may take months to build out a new BI solution, and by the time it is live, there are already new business questions that need to be answered. Additionally, sources of data are expanding faster than ever before. In the healthcare industry alone, there are electronic medical records, healthcare provider portals, and even mobile applications that are collecting massive amounts of information. This means that organizations have more data available to help drive better business decisions and derive valuable insights. Users need the flexibility to tap into this wealth of data and be empowered to answer their own questions and identify new opportunities. We have found that technical challenges can arise when trying to bring together multiple data sources within a self-service environment. More often than not, the data is at different levels of detail or granularity. Without an understanding of how the data should come together, less technical users can run into the risk of reporting inaccurate results. There are multiple use cases that we've seen across industries where self-service challenges arise. In an effort to not get overly technical with the explanation, we've highlighted a few industry-specific examples that require organizations to think critically before enabling self-service reporting for all of their users. Within the healthcare and health insurance industry, per member per month, or PMPM, is a common calculation. And actually, the use case we'll be using for demonstration purposes today. I will be explaining this use case in further detail in just a few slides. Within the pharmaceuticals industry, an organization may want to analyze their call center data against their sales data. For example, an analyst may want to be able to analyze pharmaceutical sales for individual accounts by being able to overlay information about the sales representative's interactions with the account both before and after a sale is made. In this scenario, the sales rep information is only available in the call center data, and it may be challenging to allocate sales to specific sales reps if multiple reps are involved with the account. Property and casualty insurance companies often have the need to bring together claims data and policy data. For example, as an analyst, I may want to be able to look at the claims with a policy that I have for an airline. I also want to be able to look at the individual risks that a policy insures, which could be all of the aircraft within that airline. However, claims are usually only associated with a policy, and I could run into issues when trying to associate claims with individual risks. CPG companies run advertisements through various medias that they often want to be able to tie back to their sales figures to see if advertisements had an uplift on sales. It can be challenging to see the return on investment on an advertising campaign when trying to associate advertising campaigns with the sale of a product. It is important not to inadvertently attribute more or less sales to a particular campaign. While self-service reporting challenges can arise in all industries, for this webcast, we are focusing on the healthcare industry. There are specific factors listed that impact the healthcare sector, though many of them could be applied in other areas as well. One of the most prominent factors impacting the healthcare industry is the Affordable Care Act. While there are mixed opinions on the wall, everyone can agree that it has caused major changes for health insurers and providers. Companies have had to react quickly to the changes mandated by the Affordable Care Act. The mandate for universal coverage created a need for companies to understand their new membership populations, analyze the data that is collected on them, and adjust their prices and products accordingly. In order to efficiently adjust their business practices, organizations need to empower more users to make data-driven decisions. Another key factor, certainly not specific to the health insurance industry, is the availability of information. The shift to evidence-based medicine has required insurers and providers to work together to ensure that members are receiving affordable, holistic care. This sort of relationship between insurers and providers forces a need for transparency and information sharing between them. With this level of collaboration, there is an increased concern of the security of the personal health information of individual members. In a self-service space, companies need to ensure that the right users have access to the right data. The final two factors we've identified, though there are plenty others, are industry consolidation and political uncertainties. Industry consolidation is happening at every level of the healthcare industry, with insurance companies merging and healthcare systems acquiring hospitals and providers. From a political perspective, 2016 is an important presidential election year in the United States, and healthcare has been a huge topic for debate among candidates. Healthcare organizations have already started to make the required changes mandated by the Affordable Care Act, but the changing political landscape could have an effect on additional future changes. The combination of all of these factors, as well as others, are driving the need for healthcare companies to have users that can analyze the data they are collecting and be able to make quick decisions based off that analysis. So now that we've identified the need for self-service analysis and have an understanding of its relevance to different industries, we want to look at a specific example of when self-service analysis can be challenging. For the purposes of this webcast, we will use a health insurance-specific example throughout to demonstrate the challenges that users can face when trying to perform ad hoc analysis, keeping in mind that these challenges can arise in every industry. Before we jump over to Tableau for a demonstration, let's understand PMPM a bit more. For those that work in the health insurance industry, you are very familiar with this calculation. PMPM, or per member per month, is used by healthcare companies for two main purposes. The first, and the one we're going to concentrate on today, is to use it as a metric to measure and compare costs. It is simply calculated as total costs divided by the total number of members in a given month. So if an insurance company has total costs of $1 million and has 5,000 members in January, the per member per month for January would be $200. Seems simple enough. So why is it a problem in the self-service reporting space? Some of you may have experienced this firsthand, but the data a company has on members is at an inherently different grain than their claim data. For example, a member could have one claim, multiple claims, or zero claims within a given month. However, they should only ever be counted as one member if they have multiple claims, and still be counted even if they don't have a claim. This may be easily managed in static reporting, but complexities arise when users have the need to slice and dice their data by different attributes. This may be a bit confusing, so let's break it down into what the expectation is for reporting PMPM. In this example, we have a claims table and a member table, and we need to bring data from both to calculate per member per month. In the claims table, we have a month, procedure, and claim amount, and in the member table, we have month and member month, which is just a member count for a given month. If we want to bring this data together by procedure, we would expect to add up all of the claims for a given procedure and divide that by the total member months within a time period. So in our expectation example, we are looking at 3 months of data for procedures 1, 2, and 3. We see that procedure does not have an effect on the overall member count because, in theory, any member could have any claim for any procedure. So when we're calculating PMPM for a particular procedure, we want to include the entire membership population. If we look at what actually happens when reporting PMPM on a relational database, we see that our PMPMs change, and our member months are now a subset of the overall population. If we look at procedures 1 and 2, we see a membership population of 150. That is because procedures 1 and 2 only had claims in January and February. So we're only seeing the membership population for January and February. Similarly, for procedure 3, there were only claims in January and March, so we're seeing a membership population of 130. However, a claim-specific attribute like procedure should not be affecting our overall member months. Due to this dropout, we are seeing on average higher and incorrect PMPMs for all 3 procedures. I now would like to demonstrate this issue within Tableau, a common front-end reporting tool. As we investigate PMPM, I like to assume the role of an analyst who is trying to analyze and compare costs using per member per month. So this is Tableau for those of you who aren't familiar. It is a common front-end reporting tool that's seen in a lot of organizations. And here I've connected to 2 data sources. So I've connected to claims and members, and these are just tables within an internal SQL server that we have with some sample data. So within claims, we have attributes that we would expect to see within a claim table. So DRG simply stands for diagnosis-related grouping. It's a way that a lot of healthcare companies use to group different procedures together. We also have some time series data with DIM months, this procedure information, and then we also have a claim code, and that's how we identify individual claims. In the measures, we have a few metrics. So we have the charged amount, which is the total cost, and we also have a patient count. If we jump over to our members data source, we have a bit different information here. So we're actually looking at information about our individual members. So we have things like age category, geography, gender, marital status, as well as that time series data that we have in claims. Additionally, we have different metrics here. One that we're going to be concentrating on today is the member month count. So as I said, I'm an analyst. I want to start to look at my per member per month. So within my claims, I'm going to create a calculated field that is the calculation that we identified for per member per month. So we're going to look at the sum of my charged amount, and I'm just going to simply divide that by my member month count. Click OK, and I can drag that on pretty quickly into this field in Tableau. So we see that we have a PMPM of almost $10,000. And I want to start to look at this by individual DRGs, so I can start to see which DRGs are more expensive than others. So if I pull on this DRG description to my rows, I can see that I have a DRG code as well as a description. I'm just going to space this out a little bit so we can start to see the code and the PMPM. And I actually want to look at this as a bar chart to get a visual representation. So I'm going to change this to a bar and sort on descending PMPM. So very quickly, as an analyst, I came in here, I connected to my data, and I'm looking at the most costly per member per month by DRG. Now I want to actually be able to filter on this. So I'll bring in that month name, which is shared between claims and member as a filter, and I want to look at the first quarter here. So I'll select January, February, and March, and I'll select OK. So at this point, I think, okay, I have my per member per month, everything looks good, I'm ready to report these results. But let's take a step back and actually look at the metrics that are making up this calculation and see what's going on within Tableau. So I'm going to switch back over to a tabular format so I can see my individual numbers. Again, spacing it out a bit. And I'm going to bring on charged amount alongside of my PMPM. And I'm actually going to jump back over to members and bring on that member month count. I get this warning message here that says fields cannot be used from the fact members data source because there's no relationship to the primary data source. So I'm going to click OK on this warning message, and we'll explain this in just a moment. So what I'm seeing is that for every DRG, I'm getting a member month count that's exactly the same, of 522,000. This is actually what I would expect because I want to look at my overall member month population and not have it affected by the DRG. Again, what we were showing in that chart before. But the problem is this overall number is for the entire first half of 2015. This isn't just my member months for January, February, and March, even though I have that filtered down. So I can quickly fix that within Tableau by linking those data sources because that month name that I pulled on isn't affecting those numbers at this point. So if I blend using this link here, I see that my member months change. But you may notice that these member months are not the same for every DRG. We see a 99,000 number here, and then a 65,000 number here, and even further we see 34,000. So what's really going on here? I'm going to limit this to just a few DRGs that we can concentrate on because there's a lot of noise going on. So I'm going to concentrate on these top three here. And I see, again, these three numbers are different. Well, the top two are the same, third is different. So if I actually pull this month name onto my columns next to my DRG, I start to see what's really going on here. For DRG 002 and 003, I have claims in January, February, and March. That's why I'm getting the total member month population of 99,000. If I jumped on to 058, I only have claims for January and February. So that's why I'm getting that 65,000 number. What's happening with the relational data source is that it's only associating the member population to the claim in the month that that claim was had. So very quickly we can see that our membership population is dropping out. We have tried quite a few solutions within Tableau utilizing functionality such as table calculations and parameters to solve for this issue. While these do resolve the problem in some instances, no one solution solves for every use case, and there are other challenges with this approach. Additionally, a user who may want to quickly report on PMPM may not even realize that they're calculating incorrectly, and may not have the technical skills to find a workaround solution within the front-end tool. Had we not pulled on the member count alongside PMPM above, it may not have been as apparent that the PMPMs were incorrect. Keep in mind that while we are using Tableau to demonstrate the issue, this problem is not specific to Tableau and can happen in any number of front-end tools. I'm now going to hand it back over to Paddy so he can start to explain the benefits of analysis services to provide a more robust self-service solution.
Thank you, Laura. So we looked at a specific use case where self-service BI reporting becomes challenging to implement. There are cases like PMPM in other industries too, which necessitates having a framework for robust, high-end analytical reporting. Analysis services provides just that platform. So what is analysis services? It is an online analytical data engine providing decision support and business analytic capabilities from a single platform. It leverages multidimensional concepts where business entities are identified as dimensions and metrics are identified as facts. A typical example of a dimension from a healthcare perspective would be something like members, that is those who have opted for coverage during a particular period, or the conditions they have, for instance, high blood pressure, asthma, diabetes. And an example of fact would be charged amount, which is the amount that a physician or a provider charges for a particular service that's rendered. Dimensional representation of data lends itself for slice and dice analysis. Analysis services allows users to analyze aggregated data by using a variety of tools that are intuitive, thereby providing a platform to deliver self-service business intelligence across the enterprise. One of the important or fundamental requirements that customers have with any analytical tool is the ability to restrict or provision security. Analysis services makes it easy by providing out-of-the-box security and ability to customize for handling complex scenarios. For instance, if we consider a simple scenario where only regional managers of a particular organization should be provided access to the region level data, and all other analysts within the company should be restricted to their respective state level data, this can be provisioned. Or even a more complex security requirement can be handled. In addition, analysis services leverages the corporate security so that users don't have to type in their usernames and password every time they want to connect to a data source to pull out data, and all this with their security set up in place properly. Now let's look at what a typical reporting and analytics architecture would look like. A typical reporting and analytics architecture looks like this, where a number of different source systems feed data into a relational database, which structures them, and analysts use their front-end tools to directly connect to this data source for ad hoc reporting. What we've seen with customers trying to employ this strategy on complex business problems, for instance, something like per member per month, is that they run into some of these issues that Laura highlighted earlier. The other thing to note here is that this puts the business logic in the front-end reporting tools, leaving room for calculation inaccuracies when analysts interpret the calculation or use the calculation differently. In order to get around this, a flurry of reports or workbooks or dashboards are created to try and meet dynamic reporting requirements, adding further challenges in maintaining the consistency of the definitions, but eventually not providing a full-fledged dynamic reporting solution. What we've called out as an enhanced architecture hosts analysis services, which sits in between the data layer and the front-end reporting tool and provides a platform for analytics. The key thing to note here is that it also centralizes the business logic and definition into one layer, ensuring consistency in reporting and a single version of truth across the entire enterprise. The other key thing to note here is that analysis services provides you the option of extracting the data from the underlying data source, providing high-performance analytics reporting, but can also channel requests back to the data source if the underlying data source is fast enough to support such ad hoc querying requests. It integrates with a number of front-end tools. As we could see here, we have Tableau, Excel. Analysis services can also connect to other tools like pyramid analytics, as well as custom applications. Let's look at some of the advantages of analysis services before we step in and see some demos. The primary reason for building an analysis services model is to achieve fast performance of ad hoc queries against business data. Analysis services makes it possible by means of storing aggregates of data units to provide fast answers. Within an enterprise, there are different types of users, ranging from high-level senior users, like a chief executive officer or a chief financial officer, who are more interested in looking at performance of key business metrics. And on the other side, we have analysts who are more interested in the finer details, and analysis services as a tool caters to either end of the spectrum. In addition, analysis services also stores results in a cache, and so the next instance of the same query will not need any recalculation, thereby making it extremely performance-oriented. The native tool for analysis services is Excel, which is the most commonly used tool by analysts, making adaptability easier. Analysts often want to perform comparisons with historical figures to see growth decline, and this is a standard requirement in any industry, not just specific to health insurance. Analysis services provides out-of-the-box support for time-based calculations. For instance, calculating something like an year-to-date or a quarter-to-date or moving annual totals is directly supported in the tool. One of the challenges that often come from relational-based approaches is that storing multiple years of data and doing a trend analysis is very, very difficult, especially with large volumes of data, and analysis services provides a performance benefit by doing that. In addition to all that, analysis services provides an ability to centralize definitions of calculations, thereby providing a single version of truth across the whole enterprise. We'll look at a couple of tools that work closely with analysis services before jumping into the demo. Analysis services provides dimensional data that's well suited for data exploration. Microsoft Office Excel is a native tool for analysis services. With Excel, users can explore and present data using a familiar tool. Pivot tables and pivot charts can start creating tabular reports and minimal visualizations directly within Excel. As you keep accessing different components of the analysis services data model, Excel is going to dynamically create queries to analysis services, and we could still utilize some of the features that are available already in Excel, like conditional formatting, color styles, and show or hide totals. Now at this point, we'll jump into a demo, and for this particular demo, I'm going to assume the role of an analyst from a health insurance company. I need to be able to analyze costs using per member per month. So what I have been provisioned with is a data model in analysis services which has this information. So I'm going to open a new Excel workbook and connect to analysis services by typing in the name of the server. As we could see here, I'm not typing in the username or password. I'm just going to ask analysis services to look at my corporate credentials, and it's going to connect to the data store and pull out information based on the access that I have within the environment. I'm going to connect to the health insurance model. And what we see here is that you're presented with a few options for reporting. So with a pivot table report, we could start producing tabular reports right out of the box. In addition, with pivot charts, we could create visualizations. With Power View, we can enhance those visualizations to a certain extent. Now, I'm going to stick to using a pivot table for creating a tabular report. So one of the first things that we will look at is that when Excel connects to analysis services, it opens up a pivot table and arranges the information that's available in the pivot table fields. What we see here is a list of key business metrics which I'm interested in, like charged amount, claim amount, per member per month, and a list of attributes that this data has. I want to look at the key business metrics, so I'm going to pull out charged amount, claim amount, and per member per month. When we do this, we could clearly see that as soon as we select a set of metrics, analysis services starts pulling out data. So what is really happening here is there is no data that's locally stored. Every time we make a selection, as a user, I interact with the pivot table. Excel is going to fire queries back to analysis services and pull this out. These are all near instantaneous. The data volume is not that massive, but analysis services can scale to huge data volumes. Now, we're going to look at the same problem that Lara explained in her demo, which is I'm going to pull out DRG into the rows. And for this purpose, I'm going to also filter this data to a particular month. So I pull out the calendar hierarchy and drill into the hierarchy, selecting a particular month, which is Jan 2015. And within this month, what we could see here is that all the DRGs have some claim counts, some per member per month charged amounts. I'm also going to bring member month count here just to illustrate how analysis services work. So the first significant difference that we can note here is that every DRG has the same member count. This is the fundamental problem that we had when we tried to analyze this data directly from another reporting tool with a data that's sitting directly on relational database. So we covered from that perspective that analysis services is able to establish the relationship. I'm going to quickly create another pivot table where I want to do some structured reporting. So I'm going to connect to the same data source, and in this instance, I'm going to look at data by geographies. I pick out the same set of business measures that I'm interested in, which is charged amount, claim amount, and per member per month. In addition to that, I bring in the geography hierarchy. So what we see here is that this data has data for United States country, and we see that there is a hierarchy that's inbuilt here. And pivot table provides you a quick option to expand or drill down. I'm going to drill into the state level. So within the Midwest, I can quickly go into the different levels, providing drill down capability very easily. We could also slice this data by bringing other attributes within our data model. So if I want to look at just claims for males, then I could go and select that particular filter and filter the data. Tabular reporting is one of the strong suits of Excel, and this is where it shines. In addition to that, we could leverage pivot tables, pivot charts to create visualizations that are simple enough. So I'm going to insert a pivot chart. I'll create a new data connection for it. I'm going to connect to the data source, same data source again, but instead of creating a pivot table, I'm going to create a pivot chart. So I'm interested in looking at the overall sales, overall charged amount, and claim count by the different age categories. So we could quickly see here, Excel has built a quick visualization. It's a simple visualization, it's not very complex. But in addition to looking at the data by tabular reports, we could also look at data by visualizations. So a simple dual axis chart is created where we have charged amounts plotted. In addition to that, we have a series of claim codes. I'm also going to show a simple dashboard that I pre-created prior to this particular session, where I have a limited interactivity between the different elements. So what we see here is a set of pivot tables, and these pivot tables are linked together by using slices. So slices provide a mechanism to be able to link different pivot tables that are within one particular workbook. As we could see here, the region filter basically filters age category chart. In addition to that, the state report and also the trend chart. So when I make a particular selection, that is I select Midwest, I see that immediately all these charts are getting reflected. So this is an interactive dashboard, but with a limited capability. Similarly, when I select a particular month, we could see that except for the trend report, the other two pivot tables, pivot table and the pivot chart, are getting updated automatically. And this is near instantaneous. That's because of the power of analysis services that sits behind this model, providing ability to map complex relationships and manage complex requirements. I'll hand off to Lara at this point to show how Tableau, a third-party tool, can help creating compelling dashboards.
Thanks, Paddy. So Analysis Services also has the ability to integrate with Tableau. Using Analysis Services, Tableau fires highly tuned queries and leverages calculations defined in Analysis Services, which helps with performance. Additionally, Tableau will respect the security defined in analysis services, so you don't have to worry about users accessing data they shouldn't be able to. So as Paddy mentioned, we're going to jump back into Tableau and actually start to see some of these visualizations that we can create. So I've already connected here to a cube, the same cube that Paddy did, and if I actually want to look at the data source, similarly to how he quickly connected, when you put in the server for analysis services, you can select the database and the cube that you want to use. I've already created that connection, so I'm actually going to go back and look at the DRGs and ensure that my member month counts are coming through correctly. So again, we bring on DRG. I want to bring on member month count. And you'll actually see a little warning message here. And the warning message is just saying that this metric doesn't associate with the dimension, which is what we would expect. We don't expect our DRG to be affecting our member month. And very quickly, if we pull back on that calendar month as a filter, and we filter to January, February, and March, we're seeing that 99,429 number for all DRGs, which is exactly what we need to calculate accurate per member per month. So I'm going to drag this off because I'm not interested in looking at my member month, and I want to pull on my per member per month. And what Paddy hadn't mentioned is that this is actually calculated within the cube, so the logic can be pushed down to that level, and I don't have to worry if my users are accessing from Excel or Tableau. I know that they're using the same calculation and it's being calculated correctly. So in this instance, I have a DRG and I have my per member per month. I could start to use some of Tableau's cool visuals, so I can look at this as a bar chart, or I could look at it as this packed bubble chart to see which are high impact PMPM. But for my purposes, I actually want to do a deeper dive of analysis. I don't only want to see what my per member per month is for a DRG. I want to see how many of those DRGs had, how many claims those DRGs had, so that I can start to see that not only if something's an expensive PMPM, if it also is a high impactor or if it's happening quite frequently. So if I pull on my PMPM charge onto my columns, and I'm actually going to not filter by this calendar month anymore, and I'm going to bring on claim count to rows. And what Tableau does is it automatically creates a scatter plot when I bring on two metrics. So I'm going to change this to just be detail, and I can start formatting these bubbles a bit more, so I can increase the size, and I can change the transparency so I can see where there's overlap. And very quickly, I can start to call out some of those points that might be of interest to me as an analyst. So for example, DRG002 has pretty high claim count, over 20,000, and it also has the highest PMPM of $2,648. I might even want to add some more detail to this to call out those points even faster. So Tableau 9 actually introduced this analytics panel, which has different analytics that you can pull on to your visualizations. So all of these features are available in older versions of Tableau, but it's just easier to access with this analytics pane. So I'm going to pull on some average lines to my viz, and now I start to see this division of 4 quadrants. So this top right quadrant, as an analyst, is one that I'm very interested in highlighting those DRGs. Additionally, I want to bring on some color as well. So I'm going to bring on this pre-made color I've created. So to call out which DRGs are problematic, which are okay, and which are potentially problematic. So I've used this orange, yellow, green kind of color scheme to call that out. So I'm pretty happy with this visualization, and I actually want to get into some more detailed information. So I want to see within these DRGs, within these problematic DRGs, which procedures are driving up those costs. So I want to look at the procedures and their PMPMs for these DRGs. So I'm just going to create a second sheet here where I'm going to start to look at the distribution of my procedures. So if I pull on PMPM onto my axis, my column, and I'm going to pull on procedure as my detail. And I'm going to change this using the show me function just to circles. And now I can quickly call out the distribution of procedures by PMPM. So at the top here, I have computer-assisted surgery with about $300 for PMPM, and I can see the ranges to, even the lower claims. So I want to actually bring some more detail onto this. While this is great, I want to look at other membership information and see if different membership populations have an effect on these procedures. So within my cube, I can very easily do that by bringing on age category onto my columns. And now I can see the distribution for procedures by age category. So quickly I can call out that the age range 25 to 34 has significantly lower PMPMs than the 55 to 64 age category. I want to bring on one final piece of detail here and actually break this out by gender. So I'm going to pull that on as well. And I can now see female versus male within each age category. Again, being able to call out any major discrepancies between females and males. So for 45 to 54 male, I can see this resurfacing hip for $370. And if I look down here, for the same procedure, women is only $180. Now I can format this a bit to be a little bit easier to call out some of these things. Change the transparency, actually bring gender onto color, so I can highlight men versus women. And again, from that analytics panel, I'm going to bring on something called the box plot, which helps us see the distribution of things, so by upper quartiles, lower quartiles, and then the median as well. So very quickly, I've created these two charts, and I actually want to bring them together and see how DRGs, see the certain procedures within a DRG. So if I go over here to create a dashboard, I'm going to pull on the two charts that I just created, and I'm actually going to add some interactivity between them. So I'm going to just click on this and select Use as Filter. And what this does is when I click on DRG 002, all of my procedures filter to show the procedures that are relevant to that DRG. And now I can start to call out any major differences between men and women or different age categories for specific procedures. I can call out procedures that cost a lot of money. And now I can actually start to target different age groups and genders for preventative care options. So I can target them and say, okay, well, this procedure is going to be really expensive if they have to have it. Maybe I can do something with my 55 to 64 age category to make sure that they are doing what they need to avoid that procedure. So I've actually, this is a very simple example here. We've created a final dashboard with a few more charts that we can look through, and this might be something that as an analyst, after I've gotten in here and created some charts that I like, I've come in and I want to share this on the server. So I have here PMPM and member count by month. So just to get some trending, so I have over the months my PMPM as bars. Anywhere that it's orange, it's above the average. Anywhere that it's green, it's below average. And I also have this line here that's showing our overall member month count. So we can see over time that we're actually gaining members within our population. And we can start to look at, okay, is the fact that we're having more members actually making us have higher PMPMs? Is there a correlation between the two? I also have a map here, so I can start to look at it by state. And then I have the two charts that we created together. So to show how someone might navigate this, they might want to look at the Northeast. So they'll select the filter on the left here. And we can see that all of the charts filter, similarly to how Paddy showed in Excel. Then I want to look at, okay, February had a pretty high PMPM. What's going on there? I can click on February, and I see, again, everything filters. Massachusetts has a really dense color here. That means their PMPM is quite high. So I'll select Massachusetts. And then I see that it has really one DRG that's really standing out. So I'm going to click on that. And this is where I get to that final distribution. And I would use this similarly as to how we described above. So while we demonstrated the self-service functionality of analysis services through Excel and Tableau, there are a number of other front-end tools that can leverage the power of analysis services. Here, we've identified the other common tools and their ability to integrate with analysis services. So I'm not going to go through each of these columns here, but just very quickly you can call out some tools that are used within your organization and how they would be able to interact with analysis services. So our goal for today was to share with you some of the common challenges with self-service reporting, explain how analysis services can enable users to perform complex ad hoc analysis, and then demonstrate how different front-end tools utilize the power of analysis services, and we hope that you found the session useful. As Paddy mentioned earlier, we are a specialist BI and analytics firm, but we can help with end-to-end services and are experienced in all of the engagements identified here. Please feel free to reach out to Paddy and I after the webcast if you have any questions about Thorogood or how we can help. Finally, before we move to Q&A, I want to highlight a few upcoming events that we have both within the US and the UK. If you are interested in any of these events specifically, feel free to reach out for more information on how you can register, and make sure to check our website for new events. At this time, Paddy and I will open it up to questions. If you want to ask a question, please post it in the comment section of the WebEx. If we don't get to those questions, we'll follow up with you after the event. So thank you all for joining the webcast. And again, please feel free to reach out to Paddy and I if you have any questions.